Now what we're going to do is talk about another terminal operation. This is most likely the one you'll use frequently, which is called collect. And it's very powerful, very cool. It has some more advanced uses, which we'll talk about later, probably next week. But for now, this should be enough to get you what you need for your assignments and so on. So again, we'll use the Hamlet program for this. And we're going to show a bunch of different ways to collect the results into some collection at the end of the stream. So let's talk about the class of terminal operations that return collections, which is what collect does. So collect is a terminal operation that typically returns a collection. There's some other things you can do with collect as well, but it's most commonly used to return collections. And there's a whole bunch of different variants of collections that you can return. And a bunch of them are shown in the EX12 example program. So if you want to see some more examples of how to use this stuff, then please take a look at that. So here is the program. Again, just to make this interesting, I swapped it around a little bit. So here we're going to create ourselves a list of strings, which are the character names, and they're going to be created from an array list. So we convert the array into an array list, and then we're going to go ahead and filter them, map them, and sort them. And then we're going to collect them at the end, and I'll show you a bunch of different ways to collect. In general, collect performs a so-called mutable reduction, which is kind of a funny name. And what it does is it reduces the stream. It kind of folds or merges all the elements together into a single result. And that result is typically a collection. Although it doesn't have to be a collection, it could also be some other kind of summary type of data structure if the need be. So one thing you can have is you can summarize the results, you can accumulate the elements into various types of collections and so on. We're going to be focusing on accumulating elements into various types of collections. That's the most common approach for this. So let's take a look at the simplest one. You see this used quite a bit, and this is the toList collector. So this is a collector that comes out of the box from the Java collections framework, from the Java Streams framework, and it returns a collector that knows how to collect the elements in the stream into an array list. And it's going to include all the elements in the stream, and that means there may be duplicates. You could have multiple copies of the same element, and it'll just show up in the collection that's returned from collect when you use the toList collector factory method. So toList is a factory method that makes a collector that knows how to collect the elements in the stream into an array list and includes duplicates. So those are all the things you can do with the collector that's returned from toList. We'll look in a second for other types of collectors that have different types of semantics. So you can see you've got a list of strings as the result of collecting into a list. One of the nice things about this, compared to the for each example where we used the add method, remember we had the results : add method that had the side effect. Number one, we don't have to do any initialization of this. The collector does the initialization internally, and what we get back here is a list of strings that have the results, and we don't have to do anything other than use these calls. We don't have to say, list string results equal new array list, then bloppity bloppity blop results : add in a for each loop. So it's less error prone, it's more concise, and it also scales up transparently to work with parallel streams, which is a real win, and it just comes along for the ride. So toList contains duplicates. We could also collect the results into a set. So there's also a toSet factory method that's part of the collector's utility class, and the toSet factory method, as you might expect, creates a collector, a predefined collector, that knows how to collect the elements of the stream into a set. And it actually collects it into a so-called hash set. And this particular hash set, like any other set in Java, contains no duplicates. So every element is unique. Even if you had a whole bunch of Stormtrooper elements, there's only one of them. It doesn't really matter which one, just probably the first one. There's only one element that'll be stored into the set. Anything else will be ignored. So main difference, the list could have duplicates. A set must have only unique elements, so no duplicates. And you can see just how trivially easy it is to go from a list representation that can contain duplicates to a set representation that doesn't contain duplicates. And another interesting thing here is notice that if you're going to use a set, then we don't really have to sort things. I mean, it doesn't make any sense to sort it anymore if you use a hash set, because it's not going to be sorted. It's just going to be whatever the order is. If you wanted the elements to be sorted, you'd have to use a different factory method that would create a tree set, which would then be a sorted collection that had no duplicates in it. So we don't need to do sorted here. Yet another way we can collect the data is to use toMap. So as you might expect, toMap is going to create a map instead of a set. And the particular map it uses out of the box is the hash map, which is the very common map. You can choose other maps through other factory methods, as we'll take a look at in a second. So you can make a map, and you can control what the keys are. You can control other elements of what the map is. So remember a map in Java is implemented, a hash map in Java is implemented with a hash table, which is an array. And if you remember your 201 data structures class, whenever you hash into the hash table, it goes in and looks up and it creates a hash. It uses a hash function to compute a hash value. It goes and looks in the array. It says, are there any elements there that hash to the same location? If so, then it goes ahead and sticks them initially in a linked list. So it does collision resolution through a linked list. And if the list gets big enough, it goes ahead and reconstructs the list into a balanced binary tree, which is pretty cool. So hash map is a very powerful data structure. So the elements that will go into the hash map are going to be in this case, the key, which is going to be the character's name. And so that's just basically identity. Identity simply means that it's going to be, identity simply means that take whatever comes into the stream and use that as the key. And then the values for that are going to be the length of the name, the length of the key. So it's going to be a hash map that maps the name, which is the key, to a value, which is the length of the key, the length of the name. And if you have multiple characters that have the same name, like if you had multiple versions of Hamlet or multiple versions of, let's see, I'm trying to think, maybe it was Fortinbras, I think, is it Hamlet? There's a couple of characters who have the same name. I think it's Fortinbras is the other one. What they'll do, because you can only have one element in a map, they'll simply sum together the lengths of the name. So you would end up with a longer set of values for that. So that's what toMap does. Now there's also some other even more powerful map-based collector factory methods. And one of the most interesting ones, which we'll take a look at in another context, is grouping by. And grouping by is pretty cool because you can control more aspects of how it works. In particular, you can define what type of collection, what kind of map it'll create. So here we're going to use grouping by to create a map that will have a key, a particular type of hash map, or sorry, a particular type of map, as opposed to only hash map, which is what you get with toMap. And then we also have this other thing called a downstream collector, and I'll talk about that in a second. So in this particular example, the identity method is used to say, take whatever the stream element is that comes in and use that as the key. And I like to think about that, just from a human known use perspective. That's called a classifier. And you can think about something that will bin the input in the stream into the appropriate category. So it's kind of like if you have an apartment or in your parents' house, they probably have one of these silverware drawer partitioning dividers that says, the forks go here, the big forks go here, little forks go there, the knives go here, the spoons go there, the big spoons go here, right? So it's a way of kind of classifying or mapping the input from the dishwasher or whatever into the right bin. So that's what the first element is to grouping by. It's a classifier function. And in this case, identity just returns the value of the input argument, which is the element in the stream, like the name, the Hamlet character name. The second parameter says which type of map to create. So this is a constructor reference, that's used by grouping by to make the appropriate type of map collection used to store the elements. And in this case, we're going to use a tree map. And a tree map is basically a balanced binary tree representation of a map. So you've got, like any other binary tree, you've got the element itself, and then we've got the left and the right pointers to kind of keep the tree connected in a binary tree form. And it's a balanced tree. I think it uses red-black nodes or something like that to realize the implementation. And then the third and final parameter that's passed to grouping by is something called a downstream collector. And what this does is it uses a particular built-in method called summing long, and it applies this to the results of the classification by the classifier function. So basically what we're doing here is we're saying, the key will be the name of the character in Hamlet, and then the values are going to be the sum of the length of the name of the key. And that is applied after we kind of map things to the keys. Then the downstream collector is used to create the values that are then associated with the keys. So as you can see, grouping by is very powerful, very flexible. You can determine what type of key you want. You can determine what kind of map you want. You can determine the downstream collector to make the values show up in the right place, and so on and so forth. Here's yet another example of another way to partition the input. In this particular case, rather than providing the input as an array list, which is what we do here, we're going to just have a single string, which is going to have all the names of the characters in Hamlet separated by commas. And then we're going to use the regular expression compile method, which is going to take this string and split it using this as the splitter. So the comma is the splitter. And we're going to end up with a stream of strings that have been split out of the original input. So that's just another super cool example of how you can combine streams with other stuff. And again, we use the grouping by method to group by identity, tree map, and the summing long downstream collector. That's what we talked about before. Okay, so that's kind of the overview of collect. Now, as I said before, collect is by far the most common of the terminal operations you're likely to come across. And that's really no surprise because streams are often used to take sources of data, do a bunch of transformations, and then return a collection that you can use to process the results further in other parts of your code. And we'll see some cool examples of that use case in just a second.